In this section, we're going to learn all about systems of equations. And I think this is something that a lot of you have probably seen before if you've taken like some math classes in high school and stuff like that. This is probably going to look kind of familiar. So basically, in this class, usually what I do is I give you an equation and I tell you to solve it, right? So it's an equation, you solve for x, and that's it, okay? In this chapter, I'm actually going to give you not just one equation, but two equations, and you're going to have to solve it not just for x, but both x and y, okay? So two equations, there's two variables, and you're going to have to find an x value and a y value that works for both of the equations. This is called a system of equations. Has anyone actually seen this in high school before? Yeah, some of you have seen this. I think a lot of us are kind of used to this, which is why I saved it to the end, because at least it's a little bit familiar. So why do we do systems of equations? Okay, now the systems of equations that we'll learn in this class and the ones that you've probably seen before, these are very basic, easy equations, okay? But in the real world, we do use systems of equations a lot, but it's not just two equations. Sometimes we'll have a system of equations with three equations that have both an x, y, and z. Actually, with most systems of equations, the number of variables is the number of equations. So if there's three equations, there's three variables. If there's four equations, there's four variables. Actually, you can solve a system of equations that has 10 equations and 10 variables, okay? And then you get to do something like this. If you've ever seen something like this, you might have heard it as a matrix. So matrices. If you ever heard the term matrix, that's what this is referring to. They're used very often in computer science. Any sort of coding uses this. Simulations, like weather simulations, like game design, things like this. Matrices show up all the time, okay? And this is actually the backbone to this one subject of math called linear algebra. If you ever heard that. Basically, if you are any sort of like engineering, computer science, any major that involves computers, you'll probably learn a little bit of linear algebra, which is kind of like our systems of equations, but on steroids. So it's like a lot more stuff to do. My one friend is an accounting major, and for some reason, her business classes are introducing matrices, which is kind of scary. So they're used all the time. Actually, the more equations you have, the more dimensions that you expand to. So if you have three equations, you're now in 3D and you get nice graphs like this, which is kind of fun. But we're gonna keep it simple. Don't be scared off by this crazy stuff, because we're only going to be focusing on simple systems of equations with two equations and two variables. Okay, let's flip over the page and talk about what our solutions are going to look like. So let's say that I have a system of equations. This is an example, okay? And I have a solution. Well, normally when we check to see if an answer is right, we plug it in, okay? And the same thing works with solutions for systems of equations, okay? So what we're going to do is I'm actually going to go down to part B just because I think it's a little bit easier to show you a point here. And then we'll come back to part A. But this is an example of a solution to our system, okay? And I know it looks weird as an ordered pair, but what it means is, well, the first one's x and the second number's y, okay? So basically when you see this, it's telling you that an answer to the solution is when x is 0 and y is -2. Well, if I wanted to check if this actually works with my equation, what I'll do is I'll plug it into my equations and see if it works, okay? So what I'm gonna do is I'm just gonna select the first equation. I'm gonna plug in my ordered pair and see if it works. So my first equation is 6x plus y equals -2. I'm gonna plug in 0 for x and plug in -2 for y, okay? So let's go ahead and do that. 6 times 0 plus -2 equals -2. Let's see if this works. 6 times 0 is 0. -2 is just -2. And it does look like -2 equals -2. So it seems like it works out, right? Okay. Now, even though it seems like it worked out and it worked for this equation, I'm not done until I check and see if it works for the other equation. So just because it works for equation 1 doesn't mean that it's a solution. We're actually going to plug it into equation 2, okay? So my next equation is 4x minus 3y equals 17. Let me plug in x and y into this equation, okay? 4 times 0 minus 3 times -2 equals 17. Okay. 4 times 0 is 0. 3 times -2 is -6. But if I have a minus in front of it, it's +6 equals 17. Does 6 equal 17? No, right? So that means this actually doesn't work for this equation, okay? So now we have a weird thing going on. We have a solution, right? It works for the first equation, but it doesn't work for the second equation. That's not good, okay? For this to be a solution, it has to work for both of the equations, which means that this example is not a solution, okay? So even though it works for one, if it doesn't work for both of them, then it's not good. Okay. Any questions on part B? The answer was so long and I made her write all that stuff. I'm not going to have you explain it. But let me just kind of go through with what Noelle did. So we have our two equations. I like how we made x 1/2 and y -5. Looks like Noelle plugged it in to both equations. And at the end of each equation, we got matching things on the left and right. They worked for both, which means this is a solution. Okay. Any questions on checking to see if something's a solution or not? Okay. Oh, the right side? Oh, do you want me to go over this one? Oh, yeah, okay. So I think the natural question after this is like, okay, I know how to check if a solution's right. How do I actually get the solution, right? And that's kind of what we're going to focus on today. Are you good? All right, cool. Let's go to the next page. The first, I think it's easy, but it's also kind of, I don't know, it's not the best way to do it. But one way you can find your answer is by graphing your equations, okay? Basically, when you graph two lines, wherever they intersect is a point that works for both of the lines. It's on their lines, right? So if they intersect each other, then that's a solution, okay? So basically, you're going to look where they intersect, okay? Well, I think this might be good review for the final because we have to graph some lines. Let's go and take a look at our first equation. Now, whenever you see a linear equation, which means there's like, it's just x, no x squareds or x cubes, there's always a slope and a y-intercept. Which one is the slope, 3 or 4? 3, right? The number always attached to the x is always going to be the slope, okay? So since this one has 3 attached to the x, the slope is equal to 3, okay? Which means the y-intercept, that's the other number, which has to be 4, right? So 4 is the y-intercept. Okay. Now, if I were to graph this line, I always like to start with the y-intercept because, well, the y-intercept is like a point on the graph. It's pretty easy to find because the y-intercept is where you intersect the y-axis. So I know on the y-axis, it intersects it at 4. So there has to be a point at 4, right? Now the slope is a little bit harder because slope is technically rise over run, but when slope is not a fraction, it's kind of hard to see if it's like, what are we rising and how much are we running, right? That's why I always like to turn a whole number 3 into that whole number 3 over 1, because now it's very easy to know that, okay, I'm rising up 3 and I'm running over to the right 1, okay? I can go ahead and do that for my graph, but if I rise up 3, I'm like way off my graph. So I would have a point up here, which doesn't look nice. Is there another way that I can go, well, the other direction? How much would I have to rise if I was going the other way? Would I rise at all? Yeah, you go down, right? So I would go down 3, but then I'd have to go to the left 1, right? I don't think I said that very well, but I think we all got the idea. And the reason you do that is because another way to say 3 over 1 is -3 over -1, right? So that's why you can go down 3 and to the left 1 as well. So let's go ahead and do that. Let's go 1, 2, 3. We can go to the left 1. We can graph our next point. I can even do it a bunch of times, right? Down 3 over 1, down 3 over 1. And once I get a couple points on my line, I can connect them and make my line. Cool. All right, let's do the other graph or the other line, right? I have y equals 3x minus 2. This has a slope of what number? 3 and a y-intercept of -2. Okay, I usually like to draw the y-intercept first because it's just easier to conceptualize in my brain. I know we cross the y-axis at -2, and I know the slope is 3 or 3/1. This time I really can like rise up 3, go over 1 because it fits on my graph. So I'm going to go ahead and do that and draw a couple points. And then if I connect the dots with a line, this is what my graph kind of looks like. Okay. So good. What were you about to ask? Oh, you're supposed to start at -2 and then rise 3, go over 1, right? Oh, yeah, you're good. I thought you were about to ask a different question. There actually is a question that we can ask about this, okay? Whenever we try to look for solutions to this equation, we're looking for where they intersect. So when they cross, right? Are these graphs going to cross? No, right? These graphs are what we call parallel lines, right? They are parallel. See if I can spell that, okay? And it means that, okay, they're going to go side by side and they're actually never going to intersect. They basically run by each other the whole time, okay? The reason I kind of knew that they were parallel is look at their slopes, okay? The first graph has a line or a slope of 3. The second line has a slope of 3. Since the threes match here, they're going to be parallel. They're never going to cross each other, okay? So do you think this system is going to have a solution? No, right? Systems of equations can actually not have a solution, especially when they're parallel lines. There is no solution here, okay? Because, well, the lines don't cross each other, okay? All right, let's do another example. Let's do example number 2. I think it's good practice for the final if we just kind of practice drawing these lines. How about I give you like a minute to just try and draw the lines together and then we'll come back. Keep drawing, but I actually drew my 2 lines up on the board here. Hopefully, as I was walking around, it looks like your graphs look like they were going the right direction there. So my first graph is drawn with the dark blue line. The second graph is drawn with the light blue line. Okay, so we need to figure out where the graphs intersect. And I mean, if I kind of zoom into the graph, it kind of does seem like they intersect at like 2, -5. But if you kind of zoom in even closer, they don't really exactly intersect at that line or at that square, right? It almost seems like they intersect like here at some sort of decimal spot in my coordinate plane, right? So it's definitely not intersecting at that tight corner there. It's kind of like in the middle of the block, okay? Well, we can still write our solution, and our solution is just going to be the ordered pair of that purple dot, okay? Now, taking a look at this purple dot, I need to figure out what the x value of it is first, right? What's a good estimate for what the x value should be? Anyone agree on like, I don't know, 1.6? Does that sound good? Yeah, I think it's around 1.6. I'll write that down. Okay. The y value, I'm still going to have to estimate that one. It looks like it's between -4 and -5, maybe a little bit closer to -5. Do we agree with like, yeah, -4.8? That's a little bit, that seems like about right. Okay. So it seems to me that our solution is 1.6, -4.8. Okay, so that's how you go about doing these with graphing. Now, graphing is totally fine. It is a way to kind of figure out where your solution is. But for problems like example 2, maybe you're working with an application where you need the exact decimal points, right? And it's very hard to get the exact decimal points if you just graph it and eyeball where it is, right? Sometimes you want it to the nearest 5 decimal places, and you're like, okay, well, I really can't do that using this method unless you're really good at drawing and also like seeing exactly where this thing is, okay? So that's why we're going to have a little bit, I don't know, easier methods, not easier, but more precise methods to get the solutions rather than just graphing them, which is what we're going to do on the next page. Okay, when we're solving a system of equations, I'm sure if you've seen these before, you probably saw a lot of methods to solve these. One method that people use a lot is called substitution, which I just don't think we have enough time in this class to do. To me, I think the easiest method of solving these systems is a method called elimination. Okay, has anyone heard of this before? Kind of. Yeah. Elimination to me, I think is the easiest way to solve a system of equations precisely, okay? When we do elimination, the first thing you're going to do is you're going to take your two equations and you're going to try to make both the word coefficients just means the number in front of the variable. So if you see a number in front of x, for example, that's a coefficient, okay? You want to make both of the coefficients of one variable match, but have opposite signs, okay? Number two, you're going to add together the equations and solve for one of the variables. Number three, you're going to take that variable and you're going to use it to find the other variable. If that doesn't make sense, it'll make more sense using an example. One thing I do want to say is I know that some of you probably have learned elimination a different way with subtraction. If you want to do that on the test, I'm not going to mark you wrong. As long as you get the right answer by the end and you show your steps, that's totally fine. You don't have to do these exact 3 steps if you don't want to. But let's take a look at example 3. Now, there is a typo on example 3. 16 should have an X next to it. Okay, so we're just going to draw a little X next to 16. Okay, let's say I wanted to solve this system of equations. The first thing I'm going to do is I'm going to try to make both of the coefficients of one variable match, but have opposite signs. The way I'm going to do this, and if you're wondering like why I'm doing it, I'll explain it after I do it. I'm going to take my first equation here. I'm going to take every single thing in this equation, and I'm going to multiply it by 2. Okay, so I'm going to multiply that by 2. I'm going to multiply this by 2. I'm also going to multiply that by 2, okay? And just bear with me while I'm doing this. I'll explain later, okay? But once I multiply everything by 2, what's 8x times 2? Well, what's 8 times 2? 16, right? So 8x times 2 would be 16x, right? Okay, 6y has a minus in front of it, so negative 6 times 2 is minus 12, but I have to keep the y with it, okay? And then negative 20 times 2 is minus 40, right? So I just took everything in that first equation and I multiplied it all by 2, okay? Now, the second equation, I'm not going to do anything with. I'm going to keep that the same, and I'm actually going to rewrite it by stacking all the variables underneath what I just wrote. So I'm going to take my second equation, negative 16x plus 7y equals 30, and I'm just going to copy it down. So I didn't do anything to the second equation, okay? So remember, step 1 said I needed to try to make both coefficients of one variable match but have opposite signs. I literally just did that, right? Take a look at x, right? The x variable for the first equation is 16. The x variable for the second equation is negative 16. They match and they have different signs. One's positive, one's negative. Does that kind of make sense? Cool. So the reason I chose this equation and I tried to multiply it by 2 is before I even went to the equation, I noticed that this one was 8x and this one was minus 16x. So in my head, I was like, okay, to get from 8 to 16, I need to multiply it by 2. And then I chose 2 and I multiplied it by every single thing in the equation. Okay. I multiplied by positive 2 because I knew that this one was negative and I wanted this equation to have the same coefficient but different signs. So I multiplied by positive 2 to make this positive 16. Okay. Let's take a look at step 2. Step 2 says add together the equations. Now, that might seem kind of weird at first, but it's literally what it seems like. You're going to take the 2 equations and you're going to add them, just like adding numbers, okay? All right, if I try to add these equations, what happens to the 16x and the minus 16x? Cancel out, right? So I'm just going to draw a line through those. Next, I need to add negative 12y plus 7y. How many y's am I left with? Yeah, negative 9. Yeah, perfect. Oh, is it negative? It's not negative 9, right? Did we say 5? Yeah. I just wasn't listening. I'm very bad at adding in my head. So if someone tells me what the answer is, I just think it's right. Okay. Negative 5y. Negative 40 plus 30 is negative 10, right? Okay. And now I have an equation that I can solve, right? I can divide both sides by negative 5, and I get y on the left and 2 on the right. So I got y by itself. Looks like I'm good. Now, at this point, it kind of seems like we're done. But remember, systems of equations don't have just one number as their answer. There's 2 answers. We need an x coordinate and a y coordinate. So does anyone remember from like high school how to get the other one? Yeah, right. You take one of the equations, okay, and you're going to plug in 2 for y, okay? It actually doesn't matter which equation that you choose, okay? I usually choose the equation that looks the nicest and easiest. So to me, I'm going to choose equation 1 because there's no 16 and 30 going on. I think these numbers are easier to work with. But let me write this out. I'm going to choose an equation, okay? And we can even write in our notes, it doesn't matter which, okay? Doesn't matter if I can spell this. Okay. I'm choosing the first equation, 8x minus 6y equals negative 20. Okay. And what you're going to do is you're literally going to take y and you're going to plug it into the equation. Okay. So I have 8x minus 6 times 2 equals minus 20, right? And well, we can solve this, right? 6 times 2 is minus 12 equals minus 20. This is an easy equation to solve. We can add 12 on both sides to get 8x on the left. We can get minus 8 on the right. And dividing each side by x, we get x equals negative 1. Okay, cool. We got our final answers. We have an x value. We have a y value. This is actually totally fine to write as your answer on the test. If you find your x value and your y value and you just circle them, I will give you full credit. But I mean, the mathematical way to write your answer is using ordered pairs, right? So a lot of people like to do this, and I mean, I like to do it too. I'll write the x coordinate first, negative 1. I'll write the y coordinate second and put it in an ordered pair. That's also fine. Yeah.
Sorry, so,
You're okay. Yeah.
study guide is the final questions going to be worded the same way as the study guide questions?
Yeah, I think so. Let me see. I actually don't remember what it says. But where did it go? No. Oh, this is the wrong class, that's why. Let's go to here. So at the very end of our study guide, we got something like, oh, you mean the last question? Like this one?
Yeah.
Or this one?
This is
Oh, I think it'll be worded the same. I might add a few extra directions to some of them, like I forget which one it was, but gosh. I'm not gonna surprise you too much. Yeah, yeah. That's all I'm gonna say. I'm not gonna surprise you. I think we did so much information so far that I think even that's just enough for the final, if that makes sense. Okay. Yeah, you're welcome. All right, let's do example number 4 together. Just because this is kind of new, I didn't really explain what I did in the beginning as well, so I just want to explain it again so that we have a clear idea of what to do, okay? When we see a system of equations, right, we want to take one of the equations and we want to multiply everything in that equation by a number, right? Now, taking a look at my 2 equations, which one do you think I should multiply stuff by? The first one or the second one? The second one, right? Because take a look at the numbers in the second one, right? These numbers are a lot smaller than the numbers in the first one, right? So if I need to multiply to get them to match, it wouldn't make sense for me to multiply the first equation by something because there's no way I could get them to match if I don't, well, if I multiply it by a whole number, right? So I'm definitely going to focus on the second equation, okay? And I'm going to multiply everything in the second equation by a number. Any ideas on what I could multiply it by to get them to match and have different signs? I definitely could multiply by 6, right? If I take everything here, I multiply them all by 6, okay? Let me just show you what that looks like, okay? I would get minus 6x, minus 36y equals 6 times 4 is 24, right? Cool. All right. Once we get there, my one equation, my second equation has a minus 6. My first equation has a plus 6. So they match and they have different signs, okay? What else could I multiply the equation by? How could I get the y's to match? By 2. That's a good idea. What if I multiplied everything by 2? If I did that, let's see what I get. I get minus 2x minus 12y equals 8. Now let's take a look at our y variables. Minus 12y, minus 12y. They match, but do they have the same sign? Or do they have different signs? Yeah, they have the same sign, right? We don't want them to have the same sign. We want them to have different signs. So how would I adjust what I multiply by? I wouldn't multiply by 2. I'd multiply by -2, right? So we can multiply this by -2, okay? Then that would give me, let's try it again, positive 2x plus 12y equals -8. And now if we compare our two equations, these two equations, right? The 12 matches with the -12, but they have different signs. So there's actually two options we can go about solving this question. We can either multiply by -2 or we can multiply by +6, okay? Now, looking at my two equations, personally to me, I think the -2 is easier just because I have nicer numbers. So I'm gonna do the -2, but if you went ahead and did the -6, you'd get the same answer. It'd just be a different process. So let's go ahead and do this. Okay, so I went ahead and multiplied. I need to copy my first equation though, because I didn't do anything to that one. I'm gonna stack it on top just to remind myself that this was the first equation. I'm not gonna do anything to that equation. I'm just gonna keep it the same. Okay, so it looks like they're stacked on top of each other. Now I'm free to add together the equations. What's 6x plus 2x? What's 6 plus 2? Oh, 8. Yeah, good. 8x. Honestly, the reason why I asked this is because I'm so bad at adding in my head. Even 6 plus 2 is hard for me. Okay, what happens to the y's? Cancel out. And I'm left with equals 24 minus 8 is 16. Oh, wow, you guys are better than me. That took me a while. Okay, once we get here, simple equation to solve, just divide each side by 8 and we get x equals 2.
So would 2 work for all of them? Like multiplying either equation by 2?
So if I multiplied this guy by 2, for example.
No, I'm saying like in any set, could we use 2 to like multiply either or?
It actually depends. I guess this one with 2 worked, right? And then this one -2 worked. The only reason I chose -2 is because I saw the 6 and the 12. So for example, if this was 6 and 18, then 2 wouldn't work, right? Yeah. That's a good question though. Yeah. All right. I will say that for my class, like, I'm not going to give you one where you have to multiply by like 65 or something like that, because that would just be super mean. So usually I'll stick to like lower numbers to multiply by. Okay, we got x equals 2. We're not done yet because we have to choose an equation. Which equation should I choose? Which one looks easier? Equation 1 or equation 2? 1 looks easier? What? I think 2 looks easy. Okay, we'll do 1. You're gonna put me through some mental math here though. Okay, let's choose 1. Let's choose 6x minus 12y. My first class said that too. I don't know. I like equation 2 better. But let's plug in x equals 2. 6 times 2 minus 12 times y equals 24. 6 times 2 is 12 minus 12y equals 24. And then I basically have to solve this, right? I can subtract 12 from both sides and get minus 12y equals 12. And then to get y by itself, divide by -12 and get y equals -1, right? That wasn't so bad. I don't know why I saw the 12 and the 24 and I was like, oh man, I don't want to do that in my head. Okay, how are we feeling about example number 4? Okay, this is actually where I left off with my last class. Wow, we went pretty fast today. How do we feel about leaving a little early?